Okay, Wildcats, today we're going to journal page 63, and we're going to start with Mythbusters paper fold. The myth: can a piece of paper be folded in half more than 7 times? Now what I'd like you to do is you're going to add a tab on your computer and you're going to do YouTube search Mythbusters paper fold. You're going to watch that video on YouTube and then you're going to complete the table below with the number of folds and the number of layers. Okay? Once you've done that, you're going to need an Inspire at this point. So if you're at home, you might write this down and do this portion at class, or go to Walmart or HEB or wherever they sell Inspires and grab one so you can complete this. Either way, once you have an Inspire, I want you to use the regression features of the calculator to find the equation. Okay? Now, if you have trouble with that, you might wait till you're in class and you can ask me for help, and I'll be more than willing to help you with this portion of the notes. Okay? But nonetheless, once you've got an equation, you're going to state whether the myth was busted, plausible, or confirmed. Okay, so if you would, go ahead and complete that portions of the notes. All right, now that's completed. Let's look at the next journal page. All right, exponent function transformations on page 63. F of x equals negative a times b raised to the negative x minus h plus k, where b is the base of the exponential function. The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the x inside of the parentheses, in the exponential portion of this, it reflects over the y-axis. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. Okay, if you would go ahead and complete the notes. All right, now your notes are complete. Let's take a look at the examples. All right, exponent transformations, journal page 63. Y equals a times b to the x. Tell whether the function shows growth or decay. State the y-intercept, state domain, and range. All right, if the number inside the parentheses is less than 1, it is decay. The b value is the number inside the parentheses, so 0.01. A is a number in front of the parentheses, so that's a negative 2, which is the y-intercept. So your y-intercept would be 0, negative 2. Now your domain and range. Domain is negative infinity to positive infinity. Now, because of the negative, this function normally is like this, but because of the negative, it reflects here. Okay. So then we're going from negative infinity to 0, parentheses. All right. Now, the b value is 1.2, which we know is greater than 1, so it's growth. The a value is a number from the parentheses, so that's 5, which is the y-intercept. Which in this case is 0, 5. Now, domains for exponential are always negative infinity to positive infinity. In this case, the range is 0 to infinity. All right, example 3. The b value is 0.98. Since it's less than 1, we know it's decay. The a value is 2.5, which is the y-intercept. So in this case, it's 0, 2.5. Domain is negative infinity to positive infinity, and range is 0 to infinity. All right, go ahead and finish up example 1, 2, and 3. All right, let's take a look at example 4. Now, we're going to need to use some colors in this case. So I'm going to use green black and orange. All right, so I'm going to use green to graph f of x. Now, to graph this, we know that our y-intercept is when x is 0, okay? So when x is 0, that is f of 0 equals 2 to the 0 plus 5. Well, any number raised to 0 power is 1, so 1 plus 5 is 6. So your y-intercept is 0, 6. So that's 1, 2, 3, 4, 5, 6. Now our y-intercept, our asymptote is y equals 5. And that number right there is our asymptote. So whatever the function plus that number is our asymptote. So we have a horizontal asymptote at y equals 5. Okay. Now we know exponential function goes horizontal and curves up like so. Now when we talk about transformation, I've graphed the exponential parent function f of x equals 2 to the x here. And let's go ahead and graph that in orange. Okay, so when we talk about transformations, we're talking about transformations from the parent function here. Okay, so we can see here that this graph went up 1, 2, 3, 4, 5. So your transformation is up 5 units. Okay, now domain, we know domain for exponential function is always negative infinity to positive infinity. Now the range is usually 0 to infinity, but here it's from 5 to infinity. So basically from the asymptote, not including the asymptote, to infinity. Okay? All right, let's take a look at example 5. Okay? So first things first, we need to find the y-intercept, which we know is, in this case, let's go ahead and add the plus 0. Okay? So to find that, that's when x equals 0. So f of 0 equals 2 to the 0 minus 3 plus 0. And at this point, we're going to need an inspire, so let's use that. All right, so let's plug that into our Aspire. Okay, so we're going to go to new document, no, add calculator. So we're going to do 2 up key 0 minus 3 plus 0. It's 1/8. In this case, graphing, you really need the decimal, so we're going to do control enter. It says 0.125. I'm just going to round that to 0.1. Okay. So our y-intercept is 0.1. So 0, 0.1. So really, that is about right there. That's about the best you can do is kind of approximate that. Okay. Now for the transformation, we know that the minus 3 moves the graph left 3 units. Okay. So we can move our graph left 3 units. Now, we need probably a point. We can use this point right there from the parent function, which we know is f of x equals 2 to the x. Okay, so we know that this value is going to go to the right. This point right here is to the right 3 units. So 1, 2, 3. So the transformation is right 3 units. Now the asymptote we know is 0, so y equals 0. And so we have 2 points to our graph. Now we know it's pretty much, it's hard to graph because it's so small, but it's pretty much there to there, okay? Neither of these lines touch the asymptote, but because the graph is not so great in that it's so hard to have it zoomed in that close there, we just kind of have to kind of approximate a graph there, okay? Now domain we know is from negative infinity to positive infinity, okay? And the range would be from 0 to infinity. All right, go ahead and finish up examples 4 and 5. All right, let's take a look at example 6. All right, so example 6 says, state the transformation. Okay, so it looks like we have 1, 2 transformations, okay? I know I have 3 dots. Oh, wait. No, I do have 3. 1, 2, 3, okay? So the negative reflects the x-axis. Okay, the 1/2 is a vertical compression of 1/2, and then the -2 is down 2 units. Okay. Now it says find the asymptote. The asymptote is this number right here. So y equals -2. Okay. Now to find the y-intercept, we know that's when x is 0. So when x is 0, that's f of 0 equals -1 divided by 2 times 2 to the 0 minus 2, which equals. So let's go ahead and use our calculator for that. Okay. So -1 divided by 2 times 2 to the 0 minus 2 is -5 divided by 2. Okay. So control enter. We can say that's -2.5. So our y-intercept is 0, -2.5. All right, domain we know is negative infinity to positive infinity. Now the range, because it reflected, we know we're actually coming from negative infinity, and we're going to the asymptote -2. All right, let's take a look at example 7. Okay, transformation, it looks like we have 1, 2. Okay, so that's a vertical stretch of 4, and that's left 3 units. Okay, now the asymptote, that's +0, so our asymptote's y equals 0. Now the y-intercept is when x equals 0. So that's y equals 4 times e to the 0 plus 3 plus 0 equals, and this would be a good time again to use our calculator. So that's 4. Now to find the E is this button right here underneath the triangle, okay? So 4E, and I think that's a little bright. Let's try to adjust that a little bit. E to the 0 plus 3 plus 0 is 80, and this is one decimal place, 80.3, okay? So 80.3. So your y-intercept is 0, 80.3. Okay, domain we know is negative infinity to positive infinity. Range, would be from 0 to infinity. Basically the asymptote to infinity, not including the asymptote. All right, example 8. Okay, so transformations, I count 1, 2, 3. So you have a vertical stretch of 3. You have left 2 units, and then you have down 1 unit. Okay, the asymptote is this number right here, so y equals -1. The y-intercept was when x is 0, so x equals 0. So that's f of 0 equals 3 parentheses 10 to the 0 plus 2 minus 1. And again, this would be a good time for the calculator. Okay, so then that's 3 parentheses 10 to the 0 plus 2 minus 1 is 299. Okay, so your y-intercept is 0, 299. Domain we know is always negative infinity to positive infinity, and our range is from the asymptote to infinity, so -1 to infinity. All right, if you would, go ahead and finish up journal page 63 and have a wonderful Wildcat day. Oh, almost forgot. Start working on your assignment and then have a wonderful Wildcat day.